Section 3. The ocean as a planetary regulator. As the frame widens, from Earth's deep ocean to ocean worlds, from meteorites to extremophiles, a deeper pattern begins to take shape. Oceans do more than host life. On Earth, they function as one of the planet's primary regulatory systems. They store and redistribute heat across the globe, absorb and cycle carbon, shape atmospheric chemistry, and help stabilize climate across long timescales. In that sense, the ocean is not merely an environment in which life exists. It is one of the systems that makes complex life possible at all. The ocean's thermal role is especially significant. Because water has a high heat capacity, the ocean absorbs vast quantities of energy and releases that energy far more slowly than land or atmosphere alone. This moderating effect helps reduce climatic extremes and buffers the planet against rapid temperature swings. Contemporary climate science indicates that the ocean has absorbed the majority system of excess heat generated by anthropogenic warming since the mid-20th century, making it one of the central stabilizing components of Earth's climate. Without that heat uptake, surface warming on land would be even more extreme. Ocean circulation also redistributes energy across the planet through large-scale current systems such as the Atlantic meridional overturning circulation and the broader thermohaline circulation. These slow but powerful currents transport warm water poleward and return colder water toward lower latitudes, linking regional climates into a single planetary system. At the same time, the ocean is chemically active. It absorbs carbon dioxide from the atmosphere, participates in carbonate chemistry, and stores carbon in both dissolved form and biological material. Marine photosynthetic organisms, especially phytoplankton, play a major role in global primary production and in the biological cycling of carbon through the water column. When marine organisms die, some fraction of that carbon sinks into deeper waters and sediments, helping regulate atmospheric composition over long spans of time. The ocean is therefore both a climate regulator and a carbon processing system. Its regulatory role also extends downward into the geology of the planet itself. Hydrothermal systems at mid-ocean ridges circulate seawater through hot crust, altering both the chemistry of the ocean and the mineralogy of the seafloor. The chemistry of the ocean and the mineralogy of the seafloor, sedimentation, volcanism, and water-rock interaction form a long-running exchange between ocean and crust that shapes the chemical habitability of the planet. Earth's ocean is not separate from the solid Earth beneath it. It is chemically entangled with it. This perspective has gradually influenced the scientific search for habitable worlds. Rather than focusing only on surface resemblance to Earth, researchers increasingly ask whether a planetary body possesses long-lived liquid water, persistent energy gradients, and active chemical exchange between water and rock. From that standpoint, a hidden subsurface ocean can matter just as much as a visible surface sea. What matters is not surface appearance, but whether the system can sustain chemistry over time. That shift is precisely why ocean worlds, such as Europa and Enceladus, have become so scientifically significant. They suggest that the structures supporting long-lived chemical disequilibrium, and therefore the potential for life, may not be confined to Earth-like surface environments. Instead, they may emerge wherever water, heat, and geology remain in sustained contact. On Earth, that combination produced an ocean capable not only of hosting life, but also of regulating the larger planetary system around it. Elsewhere, similar oceans may perform analogous roles in darkness beneath ice. If that pattern holds, then oceans are not simply one environmental feature among many. They are planetary engines. They absorb, buffer, circulate, transform, and remember. Earth's ocean is one example of such an engine. But it may not be the only one. The more worlds we examine, the more plausible it becomes that oceans are a recurring stabilizing architecture in the formation of habitable environments. Did you enjoy this essay? Let me know below. Like and follow for more.